Hi all, welcome to CC. Are you confused what to learn in magnetic effect of current? Then let us see what are the main topics that is to be learned in magnetic effect of current. In magnetic effect of current, the first topic that you have to give stress is Biot-Savart law. That is how to calculate the magnetic field using Biot-Savart law for a current element. Numerical questions can come from this area. So the equation of Biot-Savart law is very important. Then next is calculation of magnetic field due to a straight conductor and a circular coil using Biot-Savart law. The equations for the corresponding straight conductor and circular coil is important. And when we say straight conductor, magnetic field due to straight conductor outside and magnetic field due to the straight conductor inside. Outside it is mu 0 I by 2 pi r. Inside it is mu 0 I r by 2 pi r square. And next, calculation of magnetic field due to circular coil at the center, then at any point on the axis. Then along with circular coil, you should know how to calculate the magnetic field due to a semicircular coil or a semicircular portion. And also how to calculate the magnetic field due to an arc which is subtending an angle theta at the center. So related to this topic, numerical questions can come. Then next is Ampere's circuital law. You should know Ampere's circuital law, how to apply Ampere's circuital law, that is closed integral B dot dl is equal to mu 0 I, where I is the current enclosed by the loop, total current enclosed by the loop. And application of Ampere's circuital law. Application of Ampere's circuital law, that is to calculate the magnetic field due to a solenoid and a toroid. Solenoid magnetic field is mu 0 Ni. Toroid is also a solenoid. So the magnetic field is again, the equation is same, mu 0 Ni. Inside the solenoid and inside the toroid. Outside the solenoid, literally the field is 0. And at the ends of the solenoid, it is just half. Okay. So those equations you need to concentrate because problems will come from that region. Next is force on a current carrying wire in a magnetic field. When a current carrying conductor is placed in a magnetic field, it will experience a force ILB sin theta. So based on that, questions can come. Then when is the force maximum? When is the force 0? All these things you have to learn. That is what should be theta for force to be maximum. What should be theta for force to be minimum. And then force between two parallel current carrying conductors. When you have two conductors which are kept parallel, what is the current? Also you should know how to calculate the direction, how to find the direction. That is, if the current is flowing in the same direction, forces attractive, and forces if the current is flowing in the opposite direction, the force is repulsive. So you should know whether the force is attractive or repulsive depending on the direction of current. Then when it comes to force, you should along with this you should know Fleming's left hand rule, because sometimes questions can come asking the direction of force. So by knowing Fleming's left hand rule, you can find the direction of force. Then the next is torque on a current carrying coil in a magnetic field. This is very important because this has application. So torque on a current carrying coil in a magnetic field. So you should know what is the equation for torque, that is NIAB sin theta. What is the theta? Theta is the angle between the area vector and the magnetic field. So you should know what happens when the magnetic field is applied perpendicular to the coil, what happens when the magnetic field is parallel to the coil. So all these things you should know. And also you should know how to calculate the dipole moment. Dipole moment is current into area, I into A. So this equation, that is the torque acting on a current loop, you can write that equation as MB sin theta, where M is the magnetic dipole moment. And moving coil galvanometer. Moving coil galvanometer, actually it is an application of torque acting. That is, it works on the principle that when a current carrying coil is placed in a magnetic field, it will experience a torque. And there you should know what is galvanometer constant, what is the equation for galvanometer constant. Then what is current sensitivity? What is the equation for current sensitivity? NAB by K. K is called a torsional constant. And what is the equation for voltage sensitivity? NAB by KR. R is the resistance. And also you should know what is the deflecting torque and what is the restoring torque. Also you should know their deflection is proportional to I. And conversion of galvanometer into ammeter. Galvanometer can be converted into ammeter and voltmeter. So how you can convert a galvanometer into ammeter? By connecting a small resistance S in parallel. So when it is connected in parallel, the effective resistance, equation for effective resistance is important. That is, effective resistance becomes GS by G plus S, parallel combination. And then how to convert a galvanometer into voltmeter. A galvanometer can be converted into a voltmeter by connecting a high resistance in series. And there the equivalent resistance becomes R plus G. Since they are connected in series, it is R plus G. And then G, that is galvanometer resistance G, is equal to I minus Ig into R divided by Ig. That equation also you have to learn. Or I minus Ig into S divided by Ig. That equation also you have to learn. So from moving coil galvanometer, how to calculate current sensitivity, how to calculate voltage sensitivity. Then this conversion into ammeter and voltmeter, that is calculation of effective resistance, that portion is also important. And then the Lorentz force, Lorentz magnetic force. Lorentz force QE plus QVB sin theta. And Lorentz magnetic force is QVB sin theta. So this area is very important. Questions can be asked to find what is the force. And you should know how to calculate the cross product because direction of force can be asked. So this area is very important. And also, when is the force maximum? What happens if a particle enter perpendicular to the magnetic field? What happens if the particle is moving parallel to the magnetic field? And what happens if the particle is entering at an angle theta? So all these areas you have to cover. That is charge entering perpendicular to magnetic field. When a charged particle is entering perpendicular to magnetic field, it experiences maximum force. And force becomes minimum when it enters parallel. Then when it enters perpendicular to the magnetic field, it will follow a circular path. And the radius of the circular path is mv by qb. Then time period 2 pi m by qb. Frequency qb by 2 pi m. All these equations you have to learn. And when a charge is entering parallel to the field, then it follows a straight line path. And if the charge is entering at an angle theta, then it follows a helical path. So these are some of the points that you have to cover. So from this magnetic effect of current, this is the area that you have to concentrate. All the equations you have to learn, and apart from that, you should know when is the force maximum, when is the force minimum. All those conditions also you should know. We have started CUT UG courses in CC. If you are interested, you can join the course. You can contact using the number 9778826292. For more details, you can join our free group. Thank you.